This question asks us to find the magnetic field inside the wire from a distance r. So this in the figure we can see I have drawn the top view of the current wire. Suppose the current wire was like this. I have shown the top view of it, and because the current is uniformly distributed over the cross section of the wire, the magnetic field produced by the current is cylindrically symmetrical. So this big R is the big R is gonna be the distance from this point to here, and the magnetic field at the distance R from the origin to the wire will be calculated by drawing a loop with radius r. This is gonna be the Ampere loop. As the magnetic field is this magnetic field I have drawn is tangent to the loop. The Ampere law is given by B times our ds. B is gonna be a constant, so ds. Now we can see 2 pi r, the circumference will be given as our integration, so it's gonna be b times 2 pi r. We can see the cross-sectional area of the wire can be given by the formula pi r square. So the current passing through the unit area of the wire is the current density. So the current density will be given by current divided by pi r area, pi r square. Now the sectional area of the loop is pi r square. So the current passing through the loop, which is enclosed, will be our density times pi r square. Now our density we have found is I divided by pi r square will be pi r square here times, so it's just gonna be, this is gonna be small r. That is because the cross-sectional area of the Amperian loop, which is the loop inside, is pi r square, not the big square r, so it's the small r square. So we can't cancel this. So this is gonna be r square times r square. This pi and pi is gonna cancel out, so I'm gonna get confused with d being the diameter, so I'm gonna change d to I. So r square times r square divided by I. Now we know that according to our Ampere's law, we have integration of B times this magnetic field times ds will be given by mu naught times our density, which is enclosed. So we already have the values here, 2 pi r, B times 2 pi r, as we already solved above, and this is mu naught times our I inclusive, that is the density inclusive, is r square by r square times the I itself. So we need to isolate our B so that we can find an expression. So we can just put B here and take all this expression down here. So it's gonna be mu naught by I 2 pi r square times r square divided by r. So this r and this r is gonna cancel, so our answer is gonna be mu naught I by 2 pi r square. So in this way we can find the magnetic field inside the wire using the Ampere's law.